All right, we're going to talk a little bit about the first three problems on your independent practice, the clearing fractions practice. And there's a couple on here that are a little bit different. So if you weren't in class, then you weren't able to see these type of problems. So this will help you with that. So notice on this problem, we have parentheses. And when we did our lesson on Friday about our steps, the very first thing we do is eliminate parentheses. That is, except when we have fractions. So we want to get rid of those fractions first. They make our life a little difficult, so we want to make our life easier by getting rid of them. So we're just going to look at the fractions, and we're going to look at the denominators. We have 5 and we have 3. So we're going to decide on a lowest common multiple that both of those can go into. And remember, if we don't really see one, we can always multiply 5 times 3 and use 15. 15 in this case happens to be the lowest one. So we're going to multiply the whole equation by 15. Now here's the kicker. We do not touch these bubbles. They are protected. We cannot pop the bubbles. We're going to keep them just the way they are. So because we're going to keep them just the way they are, I'm going to rewrite them down here. And I'm going to leave them alone. I'm not going to touch the bubbles. Even if they have fractions in them, I'm not going to touch them. I'm going to clear the fractions outside of the bubbles. It's kind of like being outside the house. Before you can get to the door, you got to unlock it. So we're unlocking the door. So we say 5 can go into 15 3 times. 3 times 1 is 3. So we've taken 15 times 1/5. All we're doing is saying 15 times 1/5. And we multiply. If we want to make that look like a fraction, we can. 15 times 1 is 15. 5 times 1 is 5. 15 divided by 5 is 3. So we're just doing a quicker method of doing that. Now we're going to say, how many times can 3 go into 15? Well, 5 times. And then 5 times 1 is 5. So now we're back to the steps that we did on Friday where we solved our equation. So the first thing we do is eliminate parentheses. So 3 times 2x is 6x. 3 times a negative 1 is negative 3. 5 times x is 5x. And 5 times 4 is 20. I'm going to put my wall there just to help you. So now we have to look to see if there's any like terms. So on the left side, I have 6x minus 3. Well, there's no like terms there. They can't be combined. And on the other side, I have 5x plus 20. No like terms there. So my next step is I'm going to isolate the variable. So I have 6x and I have a 5x. I like to move my variables first, and I move the smallest one over. So this is a positive 5x. So I'm going to say minus 5x minus 5x. So 6x minus 5x gives me just a 1x. I've got to bring down my negative 3 or minus 3 because I didn't do anything to him. A positive 5x and a negative 5x cancel out, so there's no x's left on that side, and I just have a 20. So now I've isolated my variable to one side. Now I need to eliminate my constants from the variable side. So I don't want to ever take the 20 and move it because I don't want one side empty. That would be like a seesaw and one side's completely empty. So I have a negative 3, so I'm going to add 3 to both sides. So I have an x, negative 3 and positive 3 cancel out, and a 20 plus 3 gives me 23. Now, so my answer is x equals 23. So when I plug this back in to my original problem, I plug it in everywhere there was an x. So my original problem was 1/5 times 2x, so I'm going to plug in 23 where the x was, minus 1 equals 1/3 times 23, because it was the x, plus 4. So now, to check myself to see if I'm right, I'm going to solve. So 2 times 23, because I'm inside the bubble first, and I do multiplying first. So 2 times 23. Well, 20 times 2 is 40, and 2 times 3 is 6, so this is 46. 46 minus 1 is 45. So just simplify what's in the bubble. Do the same thing over here. 23 plus 4 is 27. Now I'm going to do 1/5 of 45. So this is the same thing as just multiplying. So I can multiply these straight across, or I can cross reduce. I'm going to cross reduce. So 5 can go into 5 one time, and 5 can go into 45 9 times. So I have 9 on this side. I'm going to do the same thing here. 3 can go into 3 one time. 3 can go into 27 9 times. 9 times 1 is 9. So they equal each other, so I know my solution is correct. All right, let's move on to number 2. So number 2, you'll notice on the numerators of these fractions, we have, for 2 of them, we have expressions, the 3k minus 8 and the k plus 1. So one thing that when you have this, it'll be helpful, is if you go ahead and put bubbles around these. Okay, because when we clear those fractions, we're not just multiplying the first piece, we're multiplying the whole expression. So now we're going to look at our denominators. We have 14, 7, and 2. So we think about what number can all of those go into equally that's the smallest number. Well, if I think about 7, 2 can't go into 7 easily, so 7 won't work. 2 obviously is too small for 14, and so is 7. I can multiply 7 times 2 and I get 14. So that shows me that 14 will help me clear all of these fractions. That's the lowest common multiple. So 14 will go into 14 one time. And I'm going to do 1 times everything that's on the top. And so I'm writing it out for you to see. Once you get really good at these, you can kind of skip this part, but that'll be a while. Now let's go to the next piece. So we've multiplied this one. Now we're going to multiply this one. So 7 goes into 14 2 times. 2 times 5 is 10. 2 goes into 14 7 times, and we're doing 7 times all of this. So we're going to get 7k plus 1. Okay, so remember, the fractions overrule all the steps that we did on Friday. So now we're going to look at eliminating parentheses. So we're going to go ahead and distribute. 1 times 3k, 1 times a negative 8. We didn't do anything to the 10, so we'll bring him down. 7 times k, and 7 times 1. So now we've got rid of the parentheses. Now we're going to look to see if we have any like terms. So on the left side, I have a 3k, I have a negative 8, and a positive 10 that are alike, so I can combine those together. When I have two that are different signs, I find the difference. So 10 and 8, the difference is 2, and I keep the sign of the larger one. Well, 10 was larger than 8, and it was positive, so I know it's a positive 2. Bring down my 3k. And on the right side, nothing can be combined, so I just rewrite what was there. Now, I'm isolating my variable. So I'm going to look at my variable. I have 3k, 7k. 3k is smaller, so I'm going to move it. So minus 3k, minus 3k. Cancels on this side, and I only have a 2 left. 7k minus 3k is 4k, plus 7. Now I'm going to go ahead and move my numbers, eliminate my constants from my variables. So minus 7, minus 7. A 2 minus 7 is a negative 5, equals 4k, and then these 7s would cancel out. Now when I'm here, I'm saying that 4 times k, 4 times something, equals negative 5. So to undo multiplication, I divide by my coefficient of 4 of 4. So negative 5/4 can't be reduced any. We're not changing it to a decimal or a mixed number. We leave it as an improper fraction in its simplest form. 4 divided by 4 is 1, so I'm left with just 1k. So my answer is negative 5/4. You can plug that back into your original problem and make sure you're right. All right, let's do one more. This is number 3 on your independent practice. And there is a key with these, so you can check to see, but that's why I'm looking for your process. So we're going to look at our denominators. Well, I see a denominator of 4 and 5. And if having just a number bothers you, you can put any whole number over a 1 to kind of see it as a fraction so you don't forget to do it. So we can think about that one this time. So we're going to look for the smallest number that all of these can go into, so the lowest common multiple. Well, I know that 4 can go into itself, but it can't go into 5 evenly. And I know that 5 can go into itself, but 4 won't go into it evenly. So I can just go ahead and multiply those. 4 times 5 and gives me 20. So I'm going to use 20. Now, if there happened to be one smaller and we didn't find it, we would just have to reduce more at the end. It would still be okay. So now, remember, we've got expressions on the top. So before we start, I'm going to go ahead and put those in little bubbles so I don't forget to multiply the whole expression at the top. So 4 can go into 20 5 times. So I'm going to do 5 times everything that's on top. I have a negative, so I'm going to bring it down. 1 can go into 20 20 times. 20 times 2 is 40. Or you can think about it as 20 times a negative 2. It's negative 40. 5 can go into 20 4 times, and I'm multiplying everything that's in the numerator there. So now I've gotten rid of my fractions. Now I'm going to eliminate my parentheses. So 5 times x, 5 times 3. I didn't do anything to a negative 40, so I'm going to leave it. 4 times 5, x is 20x, and 4 times a negative 2 is negative 8. So I've eliminated parentheses. Now I'm going to look for any like terms. So on my left side, I have a 5x, no other x's, but I have a positive 15 and a negative 40. Those are different signs, so I'm going to find the difference. So the difference in 40 and 15, we're finding the difference. 10 minus 5 is 5, 3 minus 1 is 2. So I know it's 25, but what kind? Well, I look at 15 and look at 40. 40 is bigger, and it was negative, so I know my answer is a negative. I'm going to bring down 5x. Didn't do anything to him. And the other side, nothing can be combined. So I'm just going to rewrite it. Now, I'm going to isolate my variable. I have a 5x on the left side and 20x on the right. So I'm going to move my smallest one over. So minus 5x, minus 5x. These cancel out. I'm left with a negative 25 over here. 20x minus 5x gives me 15x. And then bring down my negative 8. Now I want to eliminate the constant from my variable side. So I'm going to add 8, add 8. So on my right side, negative 8 and positive 8 are gone, and I'm left with just 15x. On my left side, I have a negative 25 and a positive 8. They're different numbers, so I find the difference. So think about 25 minus 8 will give me 17. And then I'll look at them and say, which one was bigger? Well, 25 is bigger, and it was negative, so my answer has to be a negative. Now, I have negative 17 equals 15x. I want to know what just one x is. So I'm going to divide by my coefficient, because 15 times x, opposite is dividing, on both sides. 15 divided by 15 is just 1, so I'm left with just 1x. And negative 17 over 15 cannot be reduced any further. Now, it is okay to have a negative 17 up top, or to have the negative out front, or to even have the negative with the 15. That's all the same thing. Okay, so this is our final answer. So continue to work through these. Remember, you can check the key to see if you're right, and also plug back into your calculator to see if you're right. These are going to be challenging, but with time and taking your time to go through the steps, using your notes will be very helpful.